Okay, welcome to this next video. We're going to be looking today at division and the division algorithm. Okay, we're still with our same learning goal. The students will be able to solve problems involving comparison, addition and subtraction about integers. So after this you're going to want to be able to apply different strategies to aid in calculation and correctly apply the division algorithm. Right, so what does division actually mean? So when you see something like maybe 6 divided by 3, what does that actually mean? What I want you to think about is that means how many 3's are in 6. Okay, so let's draw out 6, 1, 2, 3, 4, 5, 6, and we can say to ourselves, well, if I gather up 3 and I gather another 3 up, I have 2 lots of 3. Okay, so that means 6 divided by 3 is 2. Okay, unsurprising very much, but I want you to start to think that, have in your mind, that's what division means. How many 3's are there in 6? There's 2 of them. Okay, right, let's fly through to our key ideas. Okay, this symbol here shows the operation division. Okay, and so as I said before, 6 divided by 3, that's what that means. Okay, 6 divided into 3 parts. Alright, let's look at our parts of our division operation, okay, because your textbook refers to some of these. You don't have to remember these names, but maybe be reasonably familiar with it, okay. So this part here is called the dividend, okay. This bit here is called the divisor, okay, it's what does the dividing. This one here is our quotient. Oop. And sometimes we have this little bit here in the end we're going to call a remainder. Okay, now I'm happy to use remainders at the moment, but it'd be good if you could continue as we move on to go into using into decimal places. Okay, but that's for a little bit later in the year. Okay, division importantly does not follow the commutative law or the associative law. Okay, so 6 divided by 3 is not the same as 3 divided by 6. You can't just switch them around. Okay, 6 divided by 3 is 2. 3 divided by 6 is actually a half. Okay, so they're nothing like each other. You can't just switch things around like that. Okay, same with some strategies for quick division are your times tables. Again, you're like, oh, times tables, but remember things like if you know that, if you're like, 42 divided by 7 is what, you know? Well, if you know that 7 times 6 is 42, right, that means this is our missing link, so we can sort of chuck that in here. So if 7 times 6 is 42, that means that 42 divided by 7 has to be 6, okay? So that's how your times table is going to really help. Alright, you can also go about using the distributive laws. This one's a little bit harder. It's a sort of a tricky example here. So 119, we can sort of break that up into 70 plus 49, okay? So 70 plus 49 divided by 7, okay? So and now I can rewrite that as 70 divided by 7 plus 49 divided by 7. 70 divided by 7 is 10. 49 divided by 7 is 7. And I end up with 17 as my answer. Okay, so that's a pretty bit tricky one. You're going to have to be able to sort of rip numbers apart and know what they're dividing, know whether they're proper divisors and stuff. So see how you go with that one. Alright, halving the numbers if they are even. So if you have something like maybe 60 divided by 4, and you don't know your 60 times tables or 4 times tables all the way up to that one, you can divide both of these by 2 and end up with that being equal to 60 divided by 2 is 30, 4 divided by 2 is 2, and that's the same answer. 30 divided by 2 is 15. Okay, it's the same answer, it's okay to do that. Alright, when we get on to doing fractions, you might start to see why. Okay, so using the division algorithm, again, probably something you've seen before, so if you have, it's okay to fly through it, just have a look, make sure you're doing things right. So 426 divided by 4. So we write that with the 426 in here and the 4 out the front. Okay? Now we go through saying, okay, does 4 go into 4? How many times? It goes once. Okay? Does 4 go into 2? This next one. No, 4 doesn't go into 2. So what we do then is we write it goes in 0 times. Okay? So now we look at 4 going into 26. How many times does 4 go into 26? It goes in 6 times because 4 times 6 is 24. Okay? And we have 2 left over. So at the moment, we're just going to go remainder 2. Okay? Right. Next one here. So 1,125 divided by 3. Divided by 3. Okay, so again, we look at the 3 and we say how many times does 3 go into 1? Well, it goes in 0 times. Okay? How many times does 3 go into 11? It goes 3 times. Okay, now I'm going to show you long division here. It's not any more difficult. You sort of go through the same process. It probably just can help you a little bit more with stuff as you go on, because sometimes you will carry that extra number into here. Okay, I'm going to sort of show you a different way of going about that. Okay, so now we go 3 times 3 is 9. So 11 minus 9 is 2. Okay, so now we've got 3 into 22. Okay, so it's just one way to double check that you're sort of on the level with this. Okay, so now 3 into 22 is 7 times. Okay, and we carry the, that's right, there's our 2, carry that down there, there's our 22. 3 times 7 is 21. 22 minus 21 is 1. Bring the 5 down, 15. 3 into 15 is 5. And 3 times 5 is 15. 15 minus 15 is 0. We're done. Okay, so we didn't need this little 2 in there. So just be careful. I've made a little mistake there. We didn't need that in there to do our long division algorithm. Now, it's sort of the same, and we could get rid of, in the end, this 0 at the front. We don't need that. It's not helping us at all or adding anything. Oops, I've got rid of my 3. It's not adding anything to our answer there at all, so we can get rid of it. Now, they're very similar. I'm not saying the long division algorithm is better or worse. It's just, I think, it has that extra level of checking with that multiplying between them just to help you with the carrying on to the next place value. Okay? So remember, if you've seen a lot of this before, please go on to the should and could rather than sort of bogging down in the must level questions. And I look forward to seeing you at school to go through these exercises. Thank you.